Black holes. They're one of the most powerful and mysterious things of the universe. What exactly are they though? And if they're completely black, how do we find them? How do they form? And what will happen if you go near this? There are many questions surrounding black holes, and in this video series, we will try to discuss the answers. So, what is a black hole? A black hole is a region of space-time where gravity is so strong that nothing, not even light, can escape it. Now let's try to look at this definition a bit more closely. What do we mean here by escaping gravity? Suppose you have a stone in your hand and you throw it up by giving it some speed. It goes up for some distance and then comes back to ground because of Earth's gravity. If you now throw it harder, that is, if you give the rock more initial velocity, it goes further up before coming back down. Now if we keep giving the rock more and more velocity, there will come a point where the rock will just keep going up and never come back down. At this point, it will escape Earth's gravity completely. The minimum speed required to do this is called the escape velocity. Mathematically, the escape velocity v is equal to the square root of 2gm by r, where m is the mass of the earth and r is the radius of the earth. So we can see if the m is higher, escape velocity is higher. Also, if r is lower, that is, the object is more compact, the escape velocity is again higher. So Earth's escape velocity, if we calculate it using that formula, it comes out to be 11.2 kilometers per second, or about 40,000 kilometers per hour. Sun's escape velocity is much higher than this. It's about 615 kilometers per second, or about 22 lakh kilometers per hour. It's much more because it is much more massive. So, massive objects and compact objects have high escape velocity. Now, let's think a bit more deeply. We know from Einstein's theory of relativity that in the universe, the speed of light c is the highest speed achievable. So what happens when an object is so massive and so compact that its escape velocity is more than c? Then this will mean that nothing, no object, no rocket, no light or no radiation will ever be able to escape it. And this will emit no light at all. It will be a completely black hole. The idea of such an object has been around for quite some time. It was first proposed by an English astronomer, John Michell, in 1783. From Newton's theory of gravitation, he knew about the concept of escape velocity. So he proposed that there might be objects in the universe with gravity so strong that not even light will be able to escape this. He termed these things dark stars. A few years later, in 1796, French mathematician Pierre Laplace also wrote about similar ideas. After this though, no progress was made in the field for about a century. Then Einstein appeared in the scene. In 1915, he published Theory of General Relativity, and this theory directly predicted the existence of black holes. At this time, World War I was going in full swing, and physicist Karl Schwarzschild was fighting in the war. Nevertheless, during the war itself, he learned about this newly published general relativity theory. And he went ahead, got all these papers, and solved the GR equations, and this established the first concrete mathematical ideas around the black hole. Sadly, by next year in 1916, he had passed away. Within this very short time, he made very important contributions to the field of black holes. Some years later, in 1931, Indian-American astronomer Subramaniam Chandrasekhar made the first calculations of how sun-like stars die, and he predicted how white dwarfs and black holes may form. His ideas were ridiculed at his time. Astronomers of the time did not believe that such things can actually exist. But over the following decades, many astronomers and physicists slowly started to work in this area. And eventually, in 1983, Chandrasekhar won the Nobel Prize for this work. However, no one so far had any observational evidence of these things. By their very nature, black holes don't emit any light, and even though they are massive, they're extremely small, only a few kilometers across. How can we detect such a small dark object in the vast inky darkness of cosmos? Astronomers thought a lot about this, and they theorized that even though black holes don't shine, they have very strong gravity, so they can affect things around themselves gravitationally. For example, if there is a bright star nearby, the star can go around the black hole. So, if we ever see a star is going around some unseen companion, that must mean that it is orbiting a black hole. Also, there is a lot of gas generally in between stars. We call this interstellar gas. If there is interstellar gas around the black hole, the gas can fall into the hole, and while falling, the gas would become hot and it can emit X-rays. These X-rays can then be detected. So they started looking out for these kinds of phenomena. After a lot of false starts, in 1971, they finally found just such an object. It was called Cygnus X1. It is a binary system 600 light years away from us. A huge blue star is going around something unseen, and lots of X-ray is coming from that. This was the first observation of a black hole, although it took about 15 years to confirm this observation. It weighs about 21 times of our Sun. Since then, we have indirectly observed many such black holes. But the game changed again in 2019 when we got a direct picture of a black hole from the Event Horizon Telescope. Of course, we can't actually see the black hole itself. However, here in this picture, we see its shadow, that is, light passing near the black hole that is being bent around it. We see the bent light like the ring in this picture. This picture is of a very large supermassive black hole which has a mass 6 billion times of our Sun. This one is located in another galaxy, M87, which is 55 million light years away. So, now we are familiar with some of the history of these exotic objects. The next question is, how do these things form? You may have heard that black holes form when stars die, but not all stars become black holes. So what determines which star will become a black hole and exactly how? We will answer these questions in the next video of this series. So till then, thank you for watching, and if you like our content, please subscribe. See you in the next video.